Senior Scientist and Co-Director of the Research Group at ETH Zurich, and the lead developer of Compass. So I will talk a little bit about Compass before Romana then explains this collaboration with Vyzn. I think most of you don't know what Compass is, so I'll give a short overview of that. I'm going to repeat a little bit some of the things that I guess were already said earlier, but maybe in a bit slightly different context. We all know that our industry is a very multidisciplinary endeavor. It has always been the case, but this has exponentially grown in the last few decades and years, I guess. The amount of tools and solutions and technologies that are involved in a construction process are mind-blowing, I guess. That's very interesting, and that's what makes it so cool and satisfying to be in this industry. And what is also cool are all the tools and technologies and libraries and softwares that we have available to build all of these solutions. But that at the same time is also rather challenging. I mean, even seasoned programmers have a hard time and waste a lot of time making all these things talk together and integrate all of different programming languages and libraries and so on into computational workflows. And that's actually exactly what the purpose of Compass is. So to make computation in AEC simple again. And to do that, we've developed a framework that exists of a core library and then plug-and-play extensions. That is entirely platform independent, free and open source, like all of the solutions here, and provides easy access to all of the state-of-the-art libraries and tools that are out there. And the goal, of course, of all of this is to make sure that researchers, developers, people working on innovation can be productive, and that they can form sustainable collaborations, not only with the guys sitting next to them, but also with other research groups or other actors in the industry. The core library of Compass is a general purpose library that provides a geometry processing a component that is completely CAD independent, so you can use it anywhere where Python is available. It has lots of data structures that allow you to do complex data management and tag all sorts of additional metadata and geometry and etc. onto other objects and so forth. It has its own visualization and UI design toolkits, and then of course also integrations in different CAD software. And so the way a Compass is built allows you to work really with it anywhere where you can work with Python. So you can use it directly in VS Code, you can use it in Rhino, you can use it in Blender, in Grasshopper. And what is nice about it is that you can always write the same code. You don't have to switch between the different scripting syntaxes of all of these different tools. You can always work exactly the same way. And because everything in Compass is serializable to a JSON format, you can very easily move data around between all of these different tools without actually having to think about it. And so the fact that everything is JSON serializable, by the way, also makes it entirely usable in the browser with, for example, a Python server running in the background. So basically, with this core library, we provide easy access to libraries like Seagull, libIGL, ROS, OpenGL, and then tie this together with Rhino, Blender, and other CAD tools. We align this with file formats and industry standards, and then provide easy access to calculation and simulation software. And this then allows developers, research groups, people from industry that are development oriented to build extensions on top of this core framework that are inherently compatible with each other and can be reused by others and built upon and so on and so on. Over the past few years, many extensions have actually already been built. Here you see a quick overview. The range of functionality is very broad with these extensions. So, for example, here you see a coordinated robotic fabrication process with one of the that was completely organized and planned with one of the extensions. Here, a complex analysis of a discrete element structure until it only collapses if the supports move more than 40 centimeters. All the way to IFC modeling or building information modeling directly from Compass. And then these packages, they are made available to our users in all sorts of different ways. Some of them are just code libraries where you as a coder can just play around with it. Others are made available as pre-built Grasshopper components that you can just plug and play in random Grasshopper. And then even others are really provided as entire tools with a graphical user interface where you can just point and click and play around. How does this now relate to industry? Because Compass was, of course, well, not of course, but Compass was built in academia. It's very research-oriented. Was also built with a goal to make sure that researchers don't constantly reinvent the wheel and do the same thing over and over again and spend 90% of their time figuring out technical solutions instead of working on innovation. But also with the purpose in mind to bring all of this innovation actually to bridge the gap from academia to industry. And so the first step in bringing this to industry was through all these demonstrator projects where Compass was used to integrate innovative solutions that were generated in academic contexts together with industry partners to build these kind of special innovative constructions. Now in the second stage, we are more and more also seeing the adoption through small startups who can really bring their entire development pipeline all the way from early research to then bringing a product into the industry. We can do this entirely through Compass. And a big success story there, if I may say so myself, is Vaulted. Vaulted develops the Rickman floor system, which is a sustainable floor in concrete without steel and following masonry principles and so on and so on. And Vaulted is based on research that started all the way back in 2010, from early prototyping to then small projects together with research, with industry collaborators, to then the founding of Vaulted in 2023. And then further collaborations with industry partners and so on, and then now all the way to bringing these floors into a real building in Switzerland, in Zug, in the Crea Tower, which was now officially approved, where we will build 180 floors at the beginning of next year. And then another type of collaboration and a way in which Compass is useful to the industry are these collaborations around particular features, like what Max said earlier. So where we work together with people from industry to develop a specific package or a specific feature set that they can then use to build other solutions around in their company. And that's what Romana will talk about now.
Thank you, Tom. So, well, I'm sort of wearing two hats today. Good. Yeah, well, so I'm kind of wearing two hats today because I'm of course with Vision as lead of geometry processing, but I'm also a software developer since several years. So what I want to show today is a little bit what our company is doing and then how we used Compass to tackle one of our biggest challenges. So, well, this has been mentioned today already, and we all know the problems of our industry that are related to missing standards, silent thinking, missing interfaces, which ultimately leads to a missing interdisciplinary view on building projects. We lack data-supported transparency, and an early optimization of building projects is usually not possible, which leads to errors, high costs, and poor decision in the whole design to construction pipeline. And our vision is to overcome this issue by providing a consistent interdisciplinary view on certain aspects of the building projects, which should answer questions such as what is the overall impact of adding more insulation to a wall? What does it mean to reduce greenhouse gas emissions or grey energy? And what are the consequences of optimizing a given project for a better CO2 footprint? And these questions are very difficult to answer in today's planning environment, since all its sectors with their experts and data are disconnected. And we want to tackle this. So we have built a platform that allows its users to take informed and data-driven decisions. And this platform is completely browser-based, offering a shared environment for all collaborators and experts, and to allow for a comprehensive optimization process right from early planning stages. Now, how does this work? So architects and engineers upload their 3D model in IFC format onto our platform. On the platform, they can link the building elements to materials, where they either create their own materials or select from an existing well-curated and extensive material and component database. Then they can run certain analysis on the platform. For now, we offer LCA, thermal protection, energy efficiency, costs, and many more to come. And based on these results, they can either upload more geometric variants or generate more variants directly in the browser. And this, with this transparent basis and holistic approach, they can make well-informed decisions and choose a variant that satisfies their needs. Now, in order to make this workflow possible, I will dig a bit deeper into the challenge up here, because IFC models cannot be directly used onto the platform. There is some geometry processing and topological analysis needed beforehand, and this is exactly where Compass comes into play. So the IFC models we work with are usually exported from a CAD software such as ArchiCAD. And the problem is that those CAD embedded exporters are not so clever. So this IFC is unstructured, different elements belong to the wrong type, and there's usually no semantic relation between those elements. So the relation is only given by geometric proximity. Additionally, we want to keep actually the requirements of our input model slow, so users don't have to specify everything. We analyze what is implicitly there. So in the first step, what we do is to create a topological data structure that, on top of the relevant information that is contained in the IFC, also incorporates an understanding of neighboring elements and its enclosures, so you can easily extract what's inside or outside a building envelope. And this, what we call the reference model, is that basis to extract all relevant information for tools that we provide on the Vision platform. So simulation models, quantity analysis, energy performance, LCA, and so on. For the simulation model, we actually interface with Bob, another platform. And as the reference model actually automatically detects void, we can also analyze where elevators may fit in, as recently developed in a prototypical application with the company Schindler. So we built on open source. The solution is completely developed in Python, using and building upon open source libraries. So the sourcing of the IFC and the creation of the topological data structure uses the Compass ecosystem, so Compass IFC, Compass OCC, and the geometry kernel of Compass Core. And to export to Energy Plus, we also use open source tools such as Ladybug and Honeybee. And so this reference model is very crucial for us and derived from our own needs, but then also very generic. So we can describe the topological properties of buildings in general. And at Vision, over time, we will use these consistent topological models, mine it for insights, and also improve our optimization process. And this is where we wanted to give something back to the open source community, because, for example, in the first step, we did open source parts of the data structure and integrated it into the Compass framework. So coming to the end, without open source software, we would not have come this far in that short time. And to summarize, I'd like to highlight a few aspects of open source software that are important to our company. So why did we choose an open source solution such as Compass? Compass is robust, it's well tested, and it has a very motivated and dedicated developer team behind it. So it means that probably in 10, 20, 30 years from now, it will still exist. So it means that the solution that we develop now can be continuously upgraded to newer software versions. Then Compass has an MIT's license, so you can basically do everything with it. Compass has a powerful geometry kernel that will continue to grow. As well, this is close to research, so innovation that gets invented and that makes its way into the Compass framework will be accessible for us to use on our platform. Then Compass is scalable, so if we have hopefully 10,000 people on our platform that run 10,000 Compass instances, then this should not be a problem. And then Compass has interfaces to a lot of analysis tools. So whatever app we come up in the future, want to integrate on our platform as well, Compass might already have the interface for that. So why open sourcing the data structure? So actually we wanted to invoke a discussion on the reference model and on the requirements and probable extension points. So if others start to use the data structures well and try to figure out how they want to use it, it gets more tested and will ultimately generate more value than it ever can as in an isolated bubble. And then also for future collaboration, this simplifies the interface. Then how to support the Compass development. So as Tom already mentioned, actually Vision supported the development of Compass IFC financially and will continue to support Compass by code contributions, posing issues, feature requests, and so on. And with that, I pass back to...
Yeah, just to maybe briefly conclude, for those of you who know Compass, Compass 2 is out since the day before yesterday. There is also a little website that goes with it, which was launched 2 hours ago, on the train over here. And maybe what is useful for the hackathon is that on the website you can find links to small tutorials and code snippets and starter kits to, for example, make a new browser application or have Compass talk to Fast API or how to get started with Compass IFC and so on. So maybe you will find little bits and pieces there that are useful for your hacking explorations throughout the weekend. That's it. Thank you.